the folks out there today. As a fellow journeyman here in the transportation industry, I'd love to say that we are the experts about everything, but we're on this journey with you. We're learning as we go along, but we think we have some important concepts to talk about today. The whole concept of accelerating to zero or a commitment to zero touches many points. We'll talk about three of them today. As we talked among ourselves, we realized that we may have bit off a bit more than we can chew. Each one of these three topics deserves a webinar in and of itself, but we'll do our best to get through it. I should start by introducing myself. I'm Kevin Jennings. I'm the Vice President of Sales for the Western United States for Alcatel-Lucent Enterprise. It is great to be here with you today, and I'll ask you, Izzy, to introduce yourself.
Hello, everyone. My name is Israel Lopez. I am a senior ITS consultant for Triunity Engineering. I am a Big C registered communications distribution designer. I've been with Triunity for over 3 years and working in the transportation agency with transportation and ITS and transit since 2001, and in the IT arena since 1995.
Thanks, Izzy. And Roch, why don't you introduce yourself, please?
Thank you, Kevin. So good afternoon, everyone, and thank you for taking the time to listen to us today. So my name is Roch Muraine, and I'm sitting here from Paris, where it's already dark at the moment. So I'm in charge of the transportation market globally at Alcatel-Lucent Enterprise, where it covers everything which is on rail, on road, in the air, on the sea. And the subsegment ITS is most probably the most dynamic one despite the COVID-19. And visiting those customers in different countries, I see the impact of digitalization as well as innovation is transforming this market. And this is exactly what we're going to talk together all together. So back to you, Kevin. Thank you.
Thank you, Roch, and thank you, Izzy. Great to be collaborating with you on this. So we have some important topics to talk about, and this whole concept of accelerating to zero really has to do with three pillars that we'll talk about to address key goals that are important to the overall transportation community and specifically to the ITS community out there. The DOTs, various municipalities. Road fatalities continue to be a plaguing problem that everyone involved in transportation are interested in addressing, the road fatality issue. Climate change is something that's becoming more and more on the radar in North America. It's something I think that Europe is a bit ahead of us on, but it's not a question of if, it's a question of when that becomes more and more a mainstay in our decisions about where things go and how we apply different measures to deal with that. And then finally, cybersecurity is all important because the importance or mission criticality of the traffic that's traversing networks dictates that a comprehensive cybersecurity plan and strategy is ever important as we look to leverage technology toward the achievement of these other goals. And again, the unifying principle here is that of zero. You know, technology, as we seek to minimize fatalities and approach and accomplish zero fatalities, as we look to accomplish a zero carbon footprint, that will involve a zero trust network approach with the network. So the unifying principle is, in each case, there's a goal of zero, and that zero can be everything. And the unifying principle behind this is that it will require a very robust network infrastructure and ubiquitous and ever available communications, because communications is everything. Knowledge is power. Contextual communications is very important for safety. And safety is what gets us to this goal of zero fatalities. So the first in this three-legged stool, shall we say, is, you know, how can technology help us to achieve zero fatalities? I would love to say that this is a holy grail or that this in and of itself is the total solution. It's not. There are other measures such as building better roads. I think the recent infrastructure bill that was passed will go a long way toward helping us to upgrade roads, helping us to upgrade bridges. So there are some very basic things that for decades over time, we've seen that better roads, better automobiles, better technology there, that goes a long way toward toward this goal of zero fatalities. Also, information, making information available, mitigating impaired driving, education programs. There are a lot of different measures. Technology is a key part of it. It's not the only thing, but it's a key part of it. So virtually every state, every city, every town, I could have put hundreds of initiatives up on the screen here from all across the country and frankly all across the world that show the sheer commitment, how ubiquitous the commitment is to zero fatalities across the transportation industry. Now, interestingly, although there has been a general trend in recent decades toward less fatalities, in the last couple of years, fatalities have actually ticked up. And I don't know whether that's because of the COVID experience, changes in behavior patterns. I think there's been a kind of a groundswell of fatalities related to impaired driving, some of that probably related to COVID. So I think it's going to take another 10 to 20 years as we look back to try to read the tea leaves and decipher why that happened. But the general trend has been toward safety, has been toward reduction in traffic fatalities, even as the population has grown and even as more and more people have been driving on the roads. We'd like to see this continue to go down, and we think that that technology, the application of advanced technology, is one of the key factors that will help with that. We're going to talk a little bit about one specific DOT. We could talk about many. Nevada DOT, we're talking about them because we happen to know a lot about them because we work with them closely as a customer. This is their mission statement. Interestingly, their tagline, safe and connected, brings together two important concepts. We believe that connectivity is a main driver to safety, and connectivity requires advanced technology. Now, a couple of screenshots here on cameras in various parts of the world. This is normal conditions. One of the things that technology can do is to help to prevent fault conditions or prevent accidents from occurring on the road in the first place. That's a key element of the application of advanced technology. That doesn't always happen though, because we have weather conditions that come up, we have accidents that emerge, we have all kinds of fault conditions. You in the transportation community are intimately familiar with these things. So the second thing that technology can do is, if it hasn't prevented an accident in the first place, by disseminating information that will help prevent it to begin with, once it has happened, enabling first responders to respond efficiently in order to preserve life is another key element of technology. All of this depends on having a very robust network, and ITS network in place in that drive toward that goal of zero fatalities. At this point, I'm going to turn it over to Izzy, who has an extensive background in working directly with NDOT because he was there for a number of years. So let me turn it over to you, Izzy.
Thank you, Kevin. I appreciate that. I did work a number of years with NDOT. I worked as the technical ITS planner for the state on that one, working with the Traffic Operations Technology Center, guys over there on that one. But let me go ahead and tie back to zero fatalities before we start. Transportation sensors and equipment are an extension of zero fatalities. It's just a natural segue. Vehicle detection identifies traffic congestion, DMS signs, inform the public on incidents, RWIS, inform road weather conditions, CCTV cameras confirm incidents for the TMC operator. All these devices get us closer to zero fatalities model on that one. The more we have of devices, the better coverage that we can provide, the more information we can provide to the traveling public and our key stakeholders. Now, let me kind of talk about the flow of traffic, and I mean by the flow of information, really. So essentially, ITS consists of a traffic management system application that pulls field devices for sensor information. Essentially, a traffic management center collects information from field devices for the TMC operators. Those TMC operators decide on how to enable certain aspects of the system based on business, either use cases, business experience, or business rules that they've developed over time on that one. So sometimes the action is automatic, like wind warning systems, on that one. or sometimes, most of the time, the actual operator goes out to the field when the actual operator actually controls the field devices and elements on that one. So the systems are a critical part of the system, and they need to be reliable and dependable, and these systems need to be protected. Next slide, please. Okay. So essentially what happens at the center of the zero fatalities model is the Nevada data exchange. And how do we get there? We have a data exchange that shares all our information to other traffic management centers, and maintenance and construction centers as well, and transit and other traveler information. Now, understand that this system is set up to allow bi-directional communications to and from this one. So for instance, the system is set up in such a way that all the FMS systems, the freeway management systems, feed into the index. That index then feeds into our 511. But also the events that are entered into our 511 system are actually sent through the index to be archived and distributed to other centers who actually subscribe to that information. Now, the other thing is that this allows sharing of information to other divisions, departments, or sections, or other TMCs and EOCs. This is a critical part of the strategy on this one. The other thing on getting to zero fatalities and a zero trust philosophy, the system is firewalled. You can see that for the aspect of this, you can see that every entry point into the system has some type of firewall control and is firewalled because this system is exposed to the internet. It is a HTTPS. We use all the latest standards, and a standard space. We're using Traffic Management Data Dictionary. We have these interfaces. We have certificates that we apply to all our servers so that we can provide that level of service on that one. So we have zero trust from that perspective because we're trying to reach to zero fatalities on using these systems. Next slide, please. Okay. And with this here is just a very linear look of the same thing from the previous slide. We have an owning center that has the Nevada Data Exchange. We have an interface server that communicates to all the owning centers in that tier 1 on the right. We have the tier 0, which is the index. Now, the owning centers are other centers that NDOT actually had control over or wanted to communicate, like say Reno, Elko, and Las Vegas. That would be on the right. Now, external partners such as, let's say, UC Davis, UNR, and other like Waze, they would be on our left. They have a different set of rules and firewalls that we would use to protect them. So on our way to zero fatalities, we have zero trust for on the network. We don't even trust our own equipment that's part of the index. On that one. So we protect everything, and to make sure to protect the middle, which is the critical part, the database and the interfaces on that. Next slide, please. So this next slide just kind of talks about some of our key stakeholders on that one at a high level. We have obviously, we talked about District 2, District 3. We have Las Vegas. The one that's interesting about Las Vegas is that so that we understand that from a statewide perspective, we have one single platform that we currently use to manage and to manage the freeway management system. But in addition to that, the local agencies use that freeway management system to look at and control some of their devices on that one. So it's truly a regional and statewide system on that one. Our 511 system collects information from the Nevada Data Exchange because all these centers, or regional operation centers, that's what they call them there, or traffic management centers, report their information into the index. The index then takes responsibility for distribution of that information for 511 or other key stakeholders who need the information. Next slide, please. Previously, we were sharing information with Waze. We're also sharing the computer-aided dispatch information. We collect that information as well. And we share that in the Nevada Data Exchange. We're also sharing our RWIS information with NOAA, and then of course RTC of Southern Nevada is really fast, but they take our information as well. Next slide, please. So from this perspective, I wanted to kind of explain and kind of show how the breadth of our network from our perspective. So essentially what happened that you see here is you see all these lines. So all these different lines represent a fiber optic backbone that we currently share and use. Okay, so let me give you an example. The medium blue line at the top, I-80, that's 400 miles of fiber optic backbone that we share with Zayo or Level 3 or AT&T. We have close to, NDOT has close to 1,300 miles of shared use fiber optic backbone. The boxes represent the beginning and end of the link, and the circles represent NDOT fiber huts. NDOT typically places their fiber huts between 50 and 70 miles apart, depending on the need and location on that one. So the fiber optic is just so that you know that NDOT doesn't do this alone. They partnered with the state, which is the enterprise IT, which is responsible for IT for the whole state. They partnered with Nevada System of Higher Education, which also has a lot of locations similar to NDOT locations. So they manage the network. They actually are responsible for actually configuring the network equipment. NDOT IT also obviously has a lot of facilities. We're co-located with them in a lot of locations. And the traffic operations technology section is we actually have needs and cabinets and things that they're responsible. They have needs and responsibilities to provide that type of communications to all their field cabinets on that one. So it's actually a kind of like a Three Amigos kind of thing where they're sharing the information. Now, granted, NDOT IT and the traffic operations share their bandwidth, but essentially it's a 10 gig link that they share amongst all the agencies. So obviously EATS gets a third, and she gets a third, and NDOT IT and traffic operations get a third of that bandwidth, that 10 gig link. Now, so I want to go back to the diagram. The yellow line towards the left side is 70 miles of fiber. The line towards the bottom on I-15 at the California line between Las Vegas, that's about 28 miles of fiber. The purple line that goes across the center, purplish anyways, is 321 miles of fiber optic backbone. And the darker blue line between Reno and Las Vegas is about 435 miles on that one. When I left in 2018, they were still working on that one, but they were very close to finishing on that one. I wouldn't be surprised if they have that already installed, and if they are already working on, and that's not already working on from the center of the location, the end of that one, Ely, all the way down to Las Vegas for redundancy. Now, the kind of reddish lines that you see are leased lines that connect the north and south on that one, because before US 95, there was no, it's a lot of distance, so not a lot of fiber. So we were kind of, we were dependent on leased lines, and each one of those are 1 gig links that they share, or higher actually now, probably now. Next slide, please. Okay, so so I wanted to show you the width of our network. Now we'll show you the breadth of our network on this one. So here on this one, we see we have this is from our excuse me. So this is from our NDOT inventory management system from 2016. I left NDOT in 2018, so I'm positive there is more equipment than shown today. NDOT has hundreds of roadway cabinets along the freeway for CCTV cameras, beacons, and DMS signs. So as an example, that 179 that you see there equates to 179 cabinets. If you look at the screenshot up top, it's 179. At the top on that one, you can see there's 179 that's associated with that one. So with that, I just wanted to let you know that and like I said, this is from 2016. So there's been a big, they've added many more portions of the network, additional equipment on that one. They've grown, they generally grow 20 to 30% per year on that one with all the devices on that one. So with that, let's go to the next slide. Okay, in active traffic management, this is an awesome project called Project Neon. And this is part of the active traffic management structure which is installed every half mile in I-15 in Las Vegas for 18 linear miles, well, 9 miles in each direction on that one. So essentially, this is how we get to zero fatalities. Okay, these type of systems that we see here, actually reduce traffic crash rates by 20% and reduce serious crash rate reduction by 46% on that one. So these systems that we implement that for congestion management, lane control signs, you have variable speed limit signs, you know, you have travel time in this one display, you have, of course, HOV, but that can be used for anything else as well. It could be used for variable speed limit signs as well. You know, and since this is one DMS sign that spans the whole freeway, we can add variable speed limit signs by lane if necessary on that one. At least NDOT could on for sure on that one. So with that, next slide. Okay, so I'm going to have to walk you through this on this one, for this one. So before you do that, I want to kind of talk about the drawing in the center that we see here. So we have the data exchange. Since we're using standards-based protocols, which are, you know, we can communicate or change any portion of this network at any time. So we can change our 501 or ADIS or any type of ADIS system that we currently have. And since we're TMDD, it's not going to be a heavy lift. We're not going to have to change anything. We change our ATMS or FMS in the system. It's not going to be heavy lift. It's just that we will naturally fit into this one. And a little secret that most vendors won't tell you, most of like Econolite, Siemens, all the major ones, you know, kits, we've already paid as part of this project that I did for Maricopa County, working with FISO Saline. And for this particular project, a lot of the development has already been done for TMDD. You just have to ask for that. Those interfaces are already there and working. Now, do they currently work with older versions of the version of TMDD? Yes, they do, but they still work. There's a basis of work for that one. With that, I'm going to show you one of the applications that we currently have that was critical to kind of show you how the network and how much data that we're actually sharing on that one. So with that, Kevin, can you go ahead and just hover over any camera? Just pick a couple. Of course. Okay. So yeah, this camera is streaming. We don't put any limits on this and on any of the cameras. The cameras are 100% fully streaming. All cameras are available. Now, when I say all available, the ones that are available online are available. But a good portion of the cameras, I say about half of them, are not actually on the system on that one, even though there's several hundred on here. So go ahead and click on any other stream on that one. You can see that this is streaming as well.
For you to consider.
Okay, click on another one, and let's go ahead and go to devices. Once you're done with this other click,
sure.
Click on devices up on the top second from there. Go to cameras. Okay. And so scroll down. So essentially what happens, all these cameras are available. Click on any camera on that one. Just randomly click on cameras. So all these cameras are available online for the use for the traveling public. Now, we also have still images. I mean, at least NDOT does. I keep on saying that. I keep on forgetting that one. NDOT has all these cameras online, and they're available to the public. They're available through our 501 system, or they're available through our partners directly through NDOT. And they have servers on the network in their DMZ that provide and service this information. Now, there's several other different links that I have. So go ahead and click on another one. Let's say just randomly scroll down and pick any camera. So you can go farther down if you want.
Nope.
Okay, or that's fine. So you can see that these cameras are there. Continue on. Just go ahead and we'll pick one or two more cameras. Let's scroll down and let's show them on Northern Nevada. So yeah. Any one of those cameras there, so that'd be good. So obviously I-15 in Cheyenne, that's that's still in Las Vegas. Scroll, continue down, close this out. Right there, that's good. Any one of those cameras. Oh, that's still Las Vegas, unfortunately. Oh, but anyways, you get my point on this one. All the cameras are streaming and available for all our systems. We actually have a website that you can go and pull all our streams, the JPEGs and the cameras, and view them if needed on that one. And we provide this as part of our as NDOT's part of NDOT's Zero Fatalities initiative on that one. Unfortunately, that probably didn't load, or there's an issue with it. So
okay.
Okay, and one more, and then we'll call it quits. Okay, so, so like I said, let's go ahead and close this act and go back to the main presentation, please. So like I said, there are several different examples of how we can how we provide, or that NDOT is trying to get to zero fatalities, how their systems and information systems that they currently have are critical and important, that there's zero trust among all the agencies. There's firewalls in between all those locations, right. And that between external partners, and that we should be looking at locking down and securing our network, because it's a critical part, because these systems long-term can't be down. And with that, I think that's my last slide on that one, Kevin.
Thank you, Izzy. Mm-hmm. So just to kind of recap, so you've talked a lot about the NDOT case, and I think part of what having worked closely with NDOT as well, part of what they were trying to do with their network infrastructure was to look forward to a building something that would poise them to handle advanced applications. And if there's anything that could be called the holy grail of safety, of this drive towards zero fatalities, at least the more bullish about this technology believe that the connected autonomous vehicle will really help drive us in that direction. There's a lot still to be done, but I think these are coming more quickly than many think they're coming. And it's going to require a really advanced network infrastructure to be able to handle the reliability requirements of the information that's going to be taken from connected autonomous vehicles. And that's going to require a lot of roadside infrastructure with an advanced network in order to drive toward this goal of zero fatalities. So having covered the first leg of the stool here, and I know I'm mindful of our time here, let's launch into the next drive towards zero, or acceleration towards zero, and that's the area of zero carbon footprint. And I'll turn this over to Roch to talk a bit about this. I mean, we're one part of this, and looking toward your vendor and what they're doing in the area of providing solutions that have an eye towards zero carbon footprint. It's not the whole story, but it's an important part of the story. And I think, Roch, there's nobody better to talk about this than Roch. So with that, I'll turn it over to you.
Thank you very much, Kevin. And yeah, thanks a lot. So reducing carbon footprint and greenhouse gas is really definitely very high priority in the agenda in Europe, high priority agenda in ITS that attract a lot of public money. And I'm glad to see that is back as well in the agenda of America. But let's look at facts. Next slide, please. Transportation accounts for more than 33% of carbon footprint in USA, which is much more than on the rest of the world, where it's roughly 24%. However, it's in the agenda, and there's a volunteer going back to the Paris Agreement from the COP21 to become neutral by 2050. And I'm quite happy to see that two major US departments, one of transportation and one from energy, are massively investing on three directions. First one is a digitalization. Second one is everything on the renewable energy. And the last one is to improve the route between the efficiency of production and the route between production and consumption. And if I'm just focusing on one Caltrans, on one region, where Caltrans put that as well on the top 5 priority, where they see innovation and technology a strong help to solve this problem to reduce carbon footprint. At Alcatel-Lucent Enterprise, of course, we are conscious about the impact on our product into the planet. Let's move to the next slide. And this is a major reason why we build a Go Green plan with 6 directions. First one, obvious, is to make our product more energy efficient from the design side. Second one is the overall solution to be eco-friendly. Third one is to optimize the architecture, I mean the IT, network and telecom architecture, as well as the life cycle of our product. The fourth one is really to move from a full on-premises environment to a partially on premises and move the rest to the cloud, and moving as well from a software, developing all the thing in software rather than hardware, and reducing the hardware, not just in size, but as well in numbers. And just to illustrate this fact, I think on the R&D today, 90% of our R&D resources are actually focusing on software and not on hardware. And last but not least, to be part of the what I would call the green virtuous cycle, because we're asking our own supplier to be part of this cycle, reducing carbon footprint, and we are passing that through our general contractor and system integrator into the customer for their benefits. So let's move to the next slide and have a slightly more detail on few elements. Energy efficiency, of course, it's about small things that we can do, but it's about complying standards. Like all the product that has power supply must comply to 80+ and Energy Star. We're using some specific certification and standards such as 802.3 AF and AZ. Not entering into the detail, but it's basically the capability of the network where it's not used, where there's no package transiting into the IT network, simply to shut down itself, to reduce the consumption during low activity, to do dynamic power over Ethernet allocation, to adapt the speed of the fan, and as well as on the screen, for example, to according to the environment, if it's daylight or night, to play with the brightness as a contrast. And then of course, all those little things bring value in removing or reducing the energy. But it's the same as well in terms of waste, where we are looking at the recycling at the end and we have a very, very high MTBF into our product. And of course, we need to follow, and we commit to ROHS, REACH and POP, to remove all the hazardous and the chemical substance out of our products already a few years ago. Let's move to the next step, where it's really another very important way to optimize the architecture. By reducing the number of network using multi-service container, or removing one layer of aggregation, and all that without compromising on security, we can use a higher density of very high speed ports, like 25 gig, 40 gig, or 100 gig. And it is possible to replace large footprint chassis with smaller form factor virtual compact system. And of course, decreasing the number of chassis, rack space, links, you of course win a lot. And we'll talk later on about the data center, because of course, it has an impact. On the other side, deliver products to a customer, our transport operator. Can you hear me well? When we deliver the product, it means that we're going to deliver the product for 10 years or more. So definitely we need a large life span for our product. So let's move to the next slide. So on the next slide, we're talking about the evolution of the architecture, moving from on-premises to the cloud. So reducing what you deliver on premises, having all the network management converge. Sorry, it's too fast. Yes, thank you very much. So converging the wired and wireless solution into a single management and virtualizing everything. Using smart applications such as asset tracking, location-based services, all from the cloud, and having a distributed architecture, you reduce the hardware and the equipment on premises, and you remove as well the bottleneck for hardware controller. And because you do that with open standard and using highly open architecture, it's easy for us to pick the best data center, having what we call the PUE, so power usage effectiveness, where the best score is 1, And just to give you an example, we are using for Rainbow, our SaaS communication application, data center with a PUU of 1.09, where Azure or Google are having a 1.2221 score. And let's move to the last slide, next slide, sorry. We are measuring ourselves. We are asking EcoVadis to measure every year. And I'm quite proud to announce that we are part of the top 10% of the best telecom manufacturer worldwide in this sector. And with that, I will hand it over back to you, Kevin.
Thank you. Next slide. Sorry, I was muted there for a moment. I apologize. So thanks for covering that, Roch. So we've talked about the commitment to zero fatalities. We've talked about the commitment to zero carbon footprint. Just a small slice of that, exacting from your vendors a commitment to producing products that reduce carbon footprint. That's just one element. Obviously, there's a whole panoply of things to be done in that area. We've just kind of scratched the surface, but talked about an important one, because there's a lot of equipment that's deployed as part of an ITS infrastructure. We've talked a little bit about some of the things that we're doing with an eye toward zero carbon footprint, and we encourage you to set high standards in that area, because that's becoming ever more important in the race towards zero. So the third element here really gets more specifically into the network itself, and that is, let's assume that you've bought into this idea that an advanced network infrastructure is required in order to achieve or to move toward this goal of zero fatalities. So it's very important that with the criticality of the information that's traversing that network, that you have a philosophy of zero trust on the network. Well, what does zero trust mean? We'll turn it back over to Roch, because he's the gentleman really to talk about this. Between Roch and Izzy, they'll share portions of this portion of the presentation. Thank you.
Thank you very much, Kevin. So yes, meeting many IT manager or CIO, usually when I'm asking them, what is your biggest nightmare? And quite often the first answer is cybersecurity. So let's look at the next slide. Why should you care about cybersecurity? We spoke briefly about autonomous vehicle, and you definitely understand that wrong signaling, disinformation will have a huge impact on life at the end of the day. And just to tell you a story, there were in Europe a guy driving on the motorway, and the guy was driving, and in his car he was carrying hundreds of smartphones. And basically, when you were looking at Google Map or Waze, you thought the motorway was packed with traffic jam. And so people were doing everything to try to avoid these parts. And Waze was asking the people to go away from this point. So the guy was simply on his own on the motorway. So you can see that every little trick can have a big impact on the people and on the way they did. So let's move on and to see how we address this problem. So we address it with what it's called in our network industry, the zero trust network approach. And you just need to imagine your environment like an airport. And when you manage an airport, you are not thinking when you are going to have a threat. You think that the threat is already inside the airport. So you act as if the attacker were already there. You do not trust anyone, and you check and verify everything. Of course, you require the vendor to make sure that there is no backdoor in their product and solution, but that's not enough. And you need to focus on protecting the resources more than the network segment itself. No trust, no implicit trust. If on one particular area you are supposed to get a CCTV camera stream, you still need to identify, because someone could take over the camera, put a mobile or put a PC and flow the system. Adding micro-segmentation is quite critical. on the top of macro segmentation, and we will talk about that in a minute. And on the top of that, checking and controlling the identity wherever the origin, that is very important. So that is a zero trust approach. And in order to do and to apply that into the organization, we build a 5-step methodology based on the inventory, evaluation, design, simulation, and enforcement that we will cover. Now, I would like to focus for a minute on the micro segmentation and the micro segmentation. And for that, I would like to call Easy to put a spin on the, let's say, the end dot environment for it. Easy, please.
Oh, thank you, Roch. I appreciate that. So what is microsegmentation? In a nutshell, is just segmenting your different everything into different silos. For example, on the drawing that you see here on the slide, you see you have your field equipment that's connected to the field layer, and then you have your TMC layer, and then you have your center-to-center layer. These layers need to be segmented and protected against certain types of traffic. Now, one of the things that we need to identify is we need to identify the center-to-field traffic, what it is, what it's supposed to be doing, and what is typical for that traffic. Then we have the center to center, which also gathers that information, and those operators and technicians fix anything that needs to be fixed or deploy things that are new. The operators use the actionable information that they have and make decisions and choices based on the business logic of the agency. And then centers, other centers also collect and gather that information from that owning center. That owning center, the external center, then uses that information and makes decisions based off of the other owning center that has that information. So let's say for instance, NDOT has a freeway closure. We have that planned. We have all our events programmed into our 501 system. They collect that information. They're aware of that event. So when they close the roads, or preferably when they actually plan any construction, they would know about those road closures, or planned or unplanned on that one. Ideally, that's how it works. We all know it's not the case, you know what I mean? But ideally, that's that could potentially work, where you have one common view from all agencies of the incidents and events and construction events that are currently happening. So essentially what happens is we have to protect these layers. Partitioning is important because in the next slide, we're going to be talking about what happens when devices begin to talk to each other. That's not typical in that one. And that's something that we definitely want to talk about. So we obviously have a firewall. This is kind of similar to the previous slide, but now we're not looking at layers from the field to the TMC to the other centers. Now we're looking at it from the perspective of devices. So you can see the various different types of devices in their particular segment network. We have access security. We have IoT devices connecting that come in. Let's say it's your radar and portions of the network that are in that one. You have your staff members. The key takeaway from this particular perspective is that we need to authenticate our users. We need to authenticate our actual equipment. We need to provision our equipment so that we know what they are and what they do. We need to make security paramount, and that we also need to provide quality level of service for that particular type of equipment. Say, for instance, a CCTV camera, though important, will pounce on signal traffic information. So if we're pulling that signal for 30 times a second for information for real-time status. So those definitely typically should be segmented from each other, because it will cause issues with your traffic on that one. So just from a logical perspective, that traffic should be different, because there are different types of traffic on that one. One is high latency, one is just kind of high bandwidth, and it is low latency, but it's not as critical as the traffic information on that one. So one of the things that's critical, can you activate the animation on Kevin on that one, because it should show it when. So when we start seeing traffic from one device segmentation talking to the other segmentation, so let's say CCTV camera and tolling. Let's talk about a CCTV camera and DMS. Should they be talking back and forth? No, we shouldn't be seeing that traffic, and that's important. We need to classify like equipment, because then we know how they respond, and we need to make sure that each one of those silos are protected, and only normal traffic that we typically would see for that type of device are in that, and that we expect to see that. So with that, I think that I addressed all that one. So how do we get to achieve a zero trust network? So we have to inventory, we have to evaluate, design. These are the things that we typically do. This is part of the software development lifecycle. This is we're forever going in this cycle back and forth. You know what I mean? We're updating, we get new equipment, we inventory, we evaluate. Let's go to the next slide, please. And essentially, I'm going to just kind of walk you through this one. So we get a new equipment, and we get new contractors or new technicians onto our network. So we need to inventory them. We need to know who you are. Okay. And then we need to evaluate the type of traffic that's expected from them. So based off our business needs, we have business rules, that we develop over time and as best business practices. We have some compliance that we need to meet, that, okay, they need to have all the latest antivirus updates, or this needs to be the latest firmware version, whatever that might be. That applies into our design. So in that design, we segment those particular network elements or ITS equipment elements, like DMS signs, cameras, HAR, whatever, RWIZ, signals, whatever, ramp meters, whatever. Then they're specific for that type of equipment. And then we create policies off of that we know that's applicable to that equipment. Okay, and then what we do is we go and simulate that. So we beat it up from something that's something that's minor, let's say something that's wrong log on, and then we simulate all that network, and we test that network to make sure that it actually works as expected, or if there's issues or policies that we need to change or modify. Did we break something? Is everything working? Does something not quite work right? We did that in the simulation mode that verifies that is working correctly and as expected. And then we implement that one, then becomes enforcement. Okay, so this is where we log and track all that information, and we determine what traffic is legitimate, and if it's illegitimate, then we actually quarantine that traffic, and we notify the appropriate technicians that information is available with that one. So with that, I think I'll hand that over back to you, Kevin.
Okay, thank you, Izzy, and thank you, Roch, for your comments on the zero trust network approach. So we've talked about zero fatalities, zero carbon footprint, and commitment to a zero trust network implementation. So just in practical terms, key takeaway as far as looking to a network, what are the key design elements? We would encourage you to think smart. I mean, look to an advanced network, an enterprise class network that's going to deliver on the type of functionality, the type of capabilities that you need in order to further you along in that path toward zero fatalities, leveraging technology towards zero fatalities. Look at the capabilities, the commitment on the part of your vendors to zero carbon footprint, to honoring the environment that we live in. And thirdly, how robust is that network infrastructure to be able to handle a design and an implementation that's based on zero trust, which is critical because of the critical nature, the mission critical nature of the traffic that's traversing that network. So coming full circle here, you must have a very robust network in order to really make a dent in this whole challenge of zero fatalities. And I think we're going to start to see some great progress through the 2020s in that area. A big element that will contribute to that is the embrace of advanced technology, networks that provide critical functionality so that information is disseminated in a timely fashion, in a reliable fashion. These networks will be based on a zero carbon footprint commitment, or at least moving in that direction. And thirdly, those who are putting in advanced networks will have an eye toward a zero trust policy in the network, in the implementation of their network. Any final thoughts from you, Izzy, or from you, Roch, on the concepts that we talked about today?
Yeah, I have a couple thoughts on this one. On that one, let's be honest. DOTs, transit, I've worked on both sides. They're notoriously lax on network security. Firmware updates are not happening. They don't typically update their servers with server patches, updates, and releases on that one. So it's becoming a really a real big issue. It's pretty much some DOTs can be considered a honeypot for let's say if somebody does get in that network, because there's a lot of information on that one, and a lot of our equipment and devices. If somebody does a scan on that one, can actually lock them up, like on 170 controllers. If you do a network scan, and you're just seeing to see what's network, you can actually lock some of them up on that one. So there's always a concern on that one. It's not that that somebody's going to take control of it. It's that equipment won't be available to control by anyone. And that, let's say, for instance, you have 500 signals, and this is a common problem, and this is not just, this is on systems I've worked on as well and deployed. The NTCIP name, public name and private name are the same for all signals, So essentially what that means that I can, if I know the public and private name or the private name, I can go and control and send commands to any signal controller, and it will do whatever I need it to do. Because we're constantly reusing those usernames and passwords and private keys, whatever, or there's no centralized management across that one. So it is a big concern about that one.
Yeah, well, what I see on my side, if I may comment, is really that the three topics are addressed similarly all around the continents, all around the world. And it's true that innovation helps. And we had many customers, like, where we see through the traffic that putting the digitalization, putting a strong network, showing back information to the driver, save life, like we did in Canton Argos, for example, in Switzerland, or in many other motorway. I think of course, reducing the carbon footprint is very important in terms of agenda, because there is no alternative for the planet, and everybody understands that. It's not just expanding the road, or even have cleaner car or bigger car. That will not solve this issue. And last, not least, but we see a convergence of the operational technology and the IT that brings, in fact, even more capability for intruder to come into the network. So cybersecurity is really becoming even more important, because we see all those OT coming natively now with IP and Ethernet connectivity, unfortunately, most of the time without the capability of cybersecurity. So definitely, this is a very hot topic. We saw briefly how we could have a first step and a first approach from the network up to the cloud. And I think already in the time, it's a lot of information for the audience, most probably.
Yes, and I think we have about 5 minutes left, and I appreciate the comments from both of you. I don't know if we have any questions out there. I don't know. Is Rachel gathering questions if we have any, or I'm not sure how that works.
We currently don't have any questions in the Q&A pod, but our attendees can feel free to put any in if you have some in our next 5 minutes.
Okay. I think while we're waiting to see if any questions come in, I think one that's come up is it's not easy to necessarily test or draw metrics. I know Israel brought up a stat from San Diego where they had implemented technology and they saw substantial reductions in accidents, and I think that's one of the more visible cases where they believe that they have a direct correlation that they can show. In other cases, there's so many factors going on out there that it's one of the challenges is saying, okay, how do I limit my when I implement new technology? Is that the only change that's happening? Typically, it's not the only change that's happening. So there is a bit of a challenge in drawing that direct correlation. I think in general, though, we know from common sense we know from history that when you implement more advanced technology that provides more timely information, contextual information, reliably to people, it changes behavior, and that behavior results in greater safety. And I think that's the primary argument behind this. And in that quest toward zero fatalities, and in the case of zero carbon footprint, I think there's just a general groundswell of commitment in that area that waxes and wanes a little bit over time, but the general direction, the trajectory, is toward a commitment to honoring the planet and reducing carbon footprint. And I think there's a wealth
Kevin,
in that regard.
Kevin, sorry to interrupt, but there are questions, in fact. So maybe we can say that if we cannot answer all the questions, we will be at ITS America in Charlotte next week, booth 1219. So one of the questions, if you read it, how long has the asset management taken to get to this phase? And I think here's the question is toward end dot, I guess.
Yeah. It was actually a work in progress. We had worked with a web development company to actually develop that for us. For NDOT, I'm sorry, I apologize. They had started that in 2014, 2013. It was about 2016, 2015 where they started working on that one. It took several years to develop what you see and what you have, but the system was completely tailored towards for transportation on that one. So it was a unique product that's not like any other one because it was for transportation equipment.
There's another question about using Arc IT for architecture management.
Yeah, Arc IT is, obviously that's the ITS architecture that we use. Now that is to identify the relationship between entities and equipment and services on that one. That is a good beginning start, but the policies need to be very deep. From this source to this destination over this port, and is that communication is bi-directional. So when you first start this, the ITS architecture is a good start because it identifies all your key stakeholders, all your services, and then from the services you break down into protocols that they actually use for communications. NTCP, okay, well that's easy. What port are you using? Back and forth. So that goes deeper and deeper. Now, if you go into cameras, then you're talking about what are you using RTSP, multicast, on that other stuff. So that segments the network. So that's, and then you have to have a firewall that supports multicast too. It's not that simple. So there's a lot of things that you have to take into consideration. It's very deep. You know what I mean? The level of knowledge and information that you need to get there.
Well, I know that we're at the top of the hour here, and I want to honor everybody's time. If there are any other questions, we'll see if there's a mechanism to try to respond directly to them. I want to thank Israel Lopez for joining us today. I want to thank Roch for your contribution. I want to thank everybody that attended. I hope this information was helpful. It certainly was challenging for us to pull it together. We learned quite a bit on topics that we already were pretty well embedded with, and I just challenge everybody: embrace zero, accelerate to zero. These are worthy goals, and we're glad to be a part of it and contributing our part in that process. So thank you, everyone.